Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. So I hope you are all in good health and you are all okay in fine condition and ready to study. So in the last lecture we have completed the chapter current electricity. Today we are going to start the next chapter, household circuits. Okay. So let us, without wasting much time, quickly begin with the topic household circuits. Okay. So before beginning the topic or directly discussing about household circuits, today I will briefly discussing about where and how the power is being generated and how from that generating station the power reaches to your home. I will be discussing this entire path today. Okay, so let us begin. So household circuits. Okay, now see, do you see, I think all of you have observed one thing, that the power, electrical power or electrical energy that you are consuming in your homes or inside the offices, in the shops, anywhere around you, are they being generated in the locality that you are residing? I don't think so. I have not seen so far, and I hope you have also noticed this fact. Now, so where is this electrical energy being generated? Okay, so in brief I can say that electrical energy is being generated in power stations. So electrical energy is being generated in power stations. So these are generating stations, also called generating stations. From here, the power, the electrical energy that is being generated is transmitted through overhead lines. I will be briefly discussing. I am just giving you the outline. From these power stations, the electrical energy is transmitted through overhead power lines and it reaches the substations on the outskirts of the cities or villages. Okay, and from these substations the power or the energy is again transmitted to the city substations. Okay, to the city substations, which are generally located within the cities or towns or often outside the villages. Okay, and from these city substations this power is or the energy is being transferred to your house. It can be your house, it can be office, it can be school, it can be shop, it can be anything, or it is also being sometimes supplied to the industries. So the industries are being separately supplied. This can be either directly from the substations. Okay, so industries are being supplied this electrical power directly from these substations. Okay, as the industries have a higher requirement of energy, so they are generally not being supplied from the city substations. Okay, so this is a brief outline of how the power is being transmitted to your house. Okay, now first let us briefly discuss about the power stations. Okay, so let us first consider what happens in the power stations. Okay, so I think you all have a bit of idea about the power being generated using coal. Okay, so in our country still coal is a major raw material which is being utilized for producing electrical power or generating electrical energy, and a small percentage of the electrical power, total power consumed in our country is being generated through other ways, like some part of it is generated using nuclear energy, using nuclear fuels. Some part of it is being generated through hydroelectricity, hydropower. Okay, and little bit, a very small fraction up till now is being generated using the renewable resources like the wind power stations, solar power stations. Okay, but these are still now in a small percentage. However, time is changing, and with advancement of time, slowly the focus is being shifted on the renewable energy or the power generated through renewable energy. So that's why you will be seeing that the power generated using the solar panels is on an increase. It is slowly increasing. Okay. So first, what do you think? Say, if I discuss about the power station, what happens here? So let me first briefly discuss what happens in these power stations. Okay. So in these power stations, we utilize some form of raw material to generate heat. Okay. So power stations can be of the major type of power station is the thermal power stations. Okay, thermal power stations. Okay, which utilizes coal as the basic raw material. Okay, then it can be nuclear power station. Nuclear power station, where the major raw material is the radioactive elements. So raw material is the radioactive elements. Okay. Third type of power station, which is in very little use but has been a considerable share in the past, that is the gas power stations, where diesel is being used as a raw material. So gas power stations generally use diesel or say petroleum as the major raw material. Okay. Now after that comes the hydroelectricity, hydel power stations, hydel power stations. Okay, hydel power stations use what they do use? They use running water. Okay, they construct dams and use running water as a source of raw material. Running water. Okay, running water as the source of raw material. Okay. Now using this see the and the little portion uses the other renewable sources like uses the renewable sources. Okay, so within that renewable sources, within that comes the solar power station, solar power, wind power, tidal power. Okay, so these are not a great portion but a small portion. Okay, fine. Now you see so this is the brief overview of the various kinds of power stations that are being in use. Okay, so the electrical energies are being generated in these power stations, and all the power stations in the country are all connected, interconnected. Okay, now the first three types of power station, thermal power station, nuclear power station and gas power station, what they do, they generally burn the fuel, the coal, the radioactive element or the diesel and generate heat. In nuclear power plant, radioactive elements undergo fission reaction process, controlled fission reaction process, and generate a lot of amount of heat. Also in coal thermal power stations, the coal is being burnt and heat is being generated, and in gas power stations, diesels or natural gas are being burnt and that produces heat. Now this heat is being utilized to convert the water into steam. Okay, this heat that is being produced converts the water into steam, and that steam runs the turbine which generates power. Okay, while the hydel power station, what did they do? You have seen large dams being constructed at certain places. Okay, the water is being stored during the rainy season in these dams, and that stored water, what happens, is slowly released through channels, through certain channels. When the water flows down through these channels with a very high speed, what they do, they just hits the turbine blades, and rotates the turbines, which is again connected to the generator that generates electricity. In the previous three cases, the steam that is being generated has a high energy in it, which hits the turbine blades, and that makes the turbine blades rotate, which in turn rotates the generator, thus generating electricity. Okay, and in case of the other three, wind power, solar power, tidal power, the system may be different in different configurations. As in solar power stations, what happens, solar cells are being used, solar panels are being used to directly capture the sunlight, and that solar cells directly convert the sunlight or solar energy into electrical energy. The input is solar energy, output is electrical energy. Whereas the wind power stations, large windmills are constructed. When wind with a large velocity flows, they rotate the wind turbines. Wind turbines are in turn connected to the generators, and they generate electricity. Whereas in tidal power, the energy of the tides in the oceans are being utilized to rotate the turbines. So these are the very basic methods by which electricity is being generated, electrical energy is being generated in our country. Okay. Now, after this power is being generated, what happens? Generally in our country, the generators that are being used directly to generate that electricity now is generally generating power at 11,000 volt or 11 kV. So the power stations, what they are doing, the power stations are generating power at 11 kV or 11,000 volt. Okay, 11 kV. Now, after this power is being generated, what is done? After this power is being generated at 11 kV, the power has to be, the voltage of this power has to be increased, and for that step-up transformers are used. So this power that is being generated at 11 kV, it is being, the voltage is stepped up using step-up transformer. You will be reading about this transformer in the next chapter. Stepped up to say 132 kilovolt, or it can be more than this also. Okay. Now, why this voltage is being stepped up, okay, and then transmitted? The reason is that you know that power is equal to V into I. You have read this in the previous chapter. Now, for a constant power that is being supplied or that is being transmitted over the overhead lines, what happens? If we increase the voltage, the current flowing will be reduced. Now, the question arises, why the current needs to be reduced? The more the current flows through the conductors, more is the heat generated in the conductors, and that is actually one kind of loss. So the power that you are generating in the power station, when it is being transmitted over the overhead lines, is lost to some extent in the form of heat generated in the conductors. So it is tried to keep this current as low as possible, so that the heat loss is minimized, and for that what you need to do, you need to increase the voltage. Okay, so in this way we increase the voltage at the end of the power station in order to reduce the power loss in form of heat. I think you have all remembered the power generated in the conductor. It is equal to I square R into T. Heat generated in the conductor is I square R into T. So heat generated, let me write it here, heat generated is equals to I square into R into T, isn't it? Now see, this heat generated, this is actually the Joule's law of heating. I think I have missed it out while in the previous class. This is the Joule's law of heating. Please note it down. Joule's law of heating. What does the Joule's law of heating states? It states that the power heat generated in the conductor is directly proportional to the square of the current, directly proportional to the resistance of the conductor, and the time directly proportional to the time for which the current is flowing through the conductor. Okay. So the voltage is being stepped up, then it is transmitted using overhead wires to the substations. So the voltage may be stepped up more, say 132 kilovolt, then it can be stepped up to 210 kilovolt. Okay, like this it can be stepped up more also. So after stepping up the voltage using step up transformer, the power is being transmitted from the power stations to where? To the substations. So the power arises comes at the substations. Generally, see, the power stations are located far away from the locality. Why? As because the power stations obviously generates a little bit of pollution, and that can be harmful to the people. So in order to avoid that, generally the power stations are constructed out of the locality, far away from the locality. Now after this power is being transmitted to the substations are also generally located just outside the city or the rural area for which the power has to be transmitted. Okay, so the substations, in the substations, what does it does? In the substations, the voltage is being stepped down. In the substations, the voltage is being stepped down. Okay, so the voltage is stepped down. Okay, step down. So the voltage can be stepped down from, say, if the voltage has been transmitted at 132 kilovolt, so it can be stepped down from the 132 kilovolt to, say, lower voltage 33 kilovolt. Okay, 33 kV. Okay, now after this, the power is being transmitted at this voltage, at this reduced voltage, to the city substations. Now the city substations are generally located within the town, city, or maybe within the village. Okay, here the voltage is again stepped down from 33 kilovolt to, say, 10 kilovolt. Okay, so it is being reduced from 33 kilovolt to, again, say, like 10 kilovolt. Okay, 11 kV, sorry, not 10 kilovolt, 11 kV. So these are some specific values. We will be not discussing about why 11 kV and not 10 kV. It is not included in our syllabus, so it is rather a topic of higher study. So it is being stepped down to 11 kV. Then from the city substations, what does it do? The power is being transmitted to the transformers in your locality. I think all of you have noticed the transformers in your locality. So the power is being transmitted from here, from the city substations to the locality. So transformers that are present in your locality. Transformers in your locality. Here what happens? The power is, the electrical energy is again stepped down from 11 kV to 440 volt. Okay, so in these transformers what happens? The voltage is being stepped down from 11 kV to 440 volt. Okay, 11 kV to 440 volt. Okay, so it is again stepped down, and after 440 volt, the voltage at which you receive the power at your home is generally 230 to 250 volt, or say 220 to 240 volt. Okay, so in this way the power generated in the power stations reaches your home. Now see, you must have noticed that the wires from the transformer in locality entered your house through a meter box. There is a main switch and a meter box. Okay, so you must have noticed that when the at the end of say 3 months, or at some place at the end of 1 month, people come to your house and they take reading from the meter box, and accordingly you have to pay the bill. So the electrical energy is being transferred from these transformers in your locality to the house, transformer in your locality, okay, to your house, okay, at 230 volt, an estimated value, okay, 230 volt. So in this way the power actually reaches from the power stations to your house. Okay, fine. So we will be stopping our lecture here. In the next lecture we will be discussing about the connections that are being done so that the power can be transferred from the transformer into your house, how it is being connected to the main switch, the company fuse, all those things we will be discussing in the next class step by step. So in today's video we will be ending it up here. So till then, take care, and we will very soon uploading our next video. So please do wait for us, and please like our channel, subscribe our channel, and share the videos as much as possible. We are very thankful to you for your support. Okay, so till then, till the next video, take care, goodbye, thank you.